Welcome to ISC Class 11 Maths tutorial. The topic is complex numbers. Before we start, आइए आपको एक शायर की दो लाइन सुनाता हूं. वो तो खुशबू है, वो तो खुशबू है हवाओं में बिखर जाएगा. वो तो खुशबू है हवाओं में बिखर जाएगा. मसला फूल का है, फूल किधर जाएगा. मसला फूल का है, फूल किधर जाएगा. थैंक यू. Today's topic is properties of cube roots of unity. The first property is each complex cube root of unity is the square of the other. Each complex cube root of unity is the square of the other. Just see. In my previous lecture, we found out the three cube roots of unity. Out of the three cube roots of unity, these two are complex numbers. Complex cube roots of unity. This property, see, the first property is each, either this or this, each complex cube root of unity is the square of the other. Means this is the square of this, or this is the square of this. Fine. So if we call this as omega, then the property says that each complex cube root of unity is the square of the other. That means if this is omega, so omega square will be this. Alright, that is the property. Alright, I'm going to show it to you. So let's see. Each complex cube root of unity, each complex cube root of unity is the square of the other. Means the square of this is this. That's what we have written. If this is omega, then square of omega, that is omega square is this. And if you call this omega, then this will be omega square. Alright. Each complex cube root of unity is the square of the other. The square of this is this. The square of this is this. So if this is omega, then omega square will be this. So this is omega square. Now let me show you. If we take this as omega, alright, so let's find out omega square. So omega square is equal to, this is omega, no? Now let me rub this. There shouldn't be any confusion. This we are calling omega. Alright, so omega square, omega is this much, minus 1 plus root 3 I and whole divided by 2. This is omega. Omega square we are talking about. We are talking about omega square. Alright, this we are talking. Omega square. This is omega. Omega, we are finding out omega square. Alright, let's see if we are getting omega square this or not. Minus 1 minus root 3 upon 2 or not. Let's see that. So this is equal to how much then? Can we apply this? So here you apply the formula of a plus b whole square or a minus b whole square. It is up to you how much you understand, how you understand. Alright, so a plus b whole square, or you can take this as a minus b whole square. I am applying a minus b whole square. Alright, so a square means 3i square. Fine. Is that fine? A square plus b square and minus 2ab. So minus 2 root 3i and whole divided by 4. 2 square is 4. I am taking this as a and this as b, so a minus b. So a square plus b square and minus 2ab. Alright, that formula you can mention. Fine. Now I square is minus 1, so this will give you minus 3. I square is minus 1, no? So 3 into minus 1 is minus 3, so minus 3 plus 1. Let me write down, no problem. I'll write down for you. So I'll write down for you. So this gives you how much? Minus 3 plus 1. Minus 3 plus 1 and minus 2 root 3I whole divided by 4. Alright, and this you can write down. Is that fine? No? I square is minus 1, so minus 1 into 3 is minus 3 plus 1 as it is, minus 2 root 3I as it is, and 4 as it is. Okay. After this we can write down, this becomes minus 2, so we can write down then whole divided by 4, whole divided by 4, and this gives you minus 2 and again minus 2 root 3 I. Okay, minus 2 root 3. Now 2 if we take common, if we take 2 common, then we can write down, if we take 2 common, let me write here. If we take 2 common, then inside we'll get how much? Minus 1 minus root 3I and whole divided by 4. Minus 1 minus root 3I whole divided by 4. Fine. And then 2 to the 4 cancel. So you get, finally you are getting is equal to how much? Minus 1 minus root 3I whole divided by 2. Minus 1 minus root 3I whole divided by 2. Alright? So you are getting this as omega square. So that proves that each complex cube root of unity is the square of the other. Fine, clear? Okay. Now the second property is, the sum of all the 3 cube roots of unity is 0. The sum of second property is the sum of all the 3 cube roots of unity is 0. That means we are saying that 1 plus omega, because you know that the 3 cube roots of unity are 1, omega and omega square, right? This property says that 1 plus omega square is equal to 0. This property we are going to use while doing questions, and at the same time we should know how to prove it. Proof is very easy. Very easy. So let's start. Left hand side. Left hand side is equal to 1 plus omega square, and this is equal to 1 plus omega means how much? Minus 1 plus root 3I upon 2, and omega square is minus 1 minus root 3I whole divided by 2. Fine. This we have to add. Alright. This we have to add. You can extend this till here. So LCM you can take as 2. 1 upon 1. So here you can write down 1, 2. And here minus, if you agree, minus 1 plus root 3i and minus 1 minus root 3i, if you agree. This is fine. Simple addition. Okay. Now see this. This minus root 3i and plus root 3i, they cancel each other, and ultimately we are left with 2 minus 1 means 1 and 1 minus 1, right? Anyway you can write down, it is up to you. So 2 minus 1 is 1 minus 1 whole divided by 2, and this gives you 0, isn't it? Can I write down directly, because 1 minus 1 is 0? So 0 divided by 2, and that gives you 0. So this gives you 0. And this is right hand side. Right hand side. This is proved. That is the second property. 1 plus, so we got 1 plus omega square equal to 0. Once again you can write down. Therefore 1 important property. 1 plus omega square is equal to 0. This is the property. 1 plus omega square equal to 0. Please remember this property. We are going to use this property when we'll do exercise questions. Fine. Clear? Now the third property is the product of the three roots. The product of the three cube roots of unity is 1. Third property. The product of that means the three cube roots of unity are 1 omega and omega square, right? 1 omega and omega square. These are the three cube roots of unity, and this property says that the product of these three is 1. That means 1 into omega and into omega square is equal to 1. This we have to show. Alright. Is equal to this we have to show. And actually this means what? Omega cube. So that is omega cube is equal to 1. This we have to show. Omega cube is equal to 1. This we have to show. This is the result. Property, we will be using this property when we solve exercise. Fine. Okay. So let me show. It. Okay. So left hand side is equal to 1 into omega square. Alright, and this gives you 1. We don't write only. If you wish to write down, please write down in this step, and then after that we will not write down. Minus 1 plus root 3i whole divided by 2, and into minus 1 minus root 3i. This is the other root, this second root. There are two complex cube roots of unity. Fine. Now 1 we will not write down because multiplication, no. So 1 is not going to make any difference when we multiply. Can I rub this? Yes. Now this is equal to, this we can write down, this is equal to, now see this, a minus, okay, we have to multiply this into this. What we can do, now it is up to you how you are going to simplify. This is how I am doing. Alright, but you can do in your own way, whichever way you find easier. Now we are multiplying this into this. If I take minus outside, you can do like this also. See, a plus b and a minus b, where a is, this is a, this you can call as a, this as b, this as a, and this as b. So don't you see that? Don't we see that a plus b and a minus b? Right? Which is a square minus b square. Fine. So that we can write down. When we multiply, we can write down a square means minus 1 square. Alright. So a square minus b square means root 3i whole square. Root 3i whole square. And whole divided by 2 into 2 is 4. Is that fine? Okay, now after this minus 1 square is 1. Alright, this is 1, and minus this will be 3i square. Root 3 square is 3 and I square, so 3i square. And whole divided by 4. Is that fine? Now this we can write down 1, and I square is minus 1, so that minus 1 and minus 3. Minus 3 into minus 1 is plus 3. Alright. Whole divided by 4. And this gives you 4 whole divided by 4. And this gives you 1. And this is your right hand side. Alright. Which is equal to right hand side. Right hand side. Proved. You can write down here. Proved. Hence proved. So we proved that omega cube is equal to 1. Clear? That is the third property. Now the fourth property is fourth. The fourth property is each complex cube root of unity is the reciprocal of the other. Each complex cube root of unity, fourth property. Each complex cube root of unity is the reciprocal of the other. Alright. Now, the two complex cube root of unity are, we can write down yes, we can write down like that. Let alpha is equal to minus 1 plus root 3i whole divided by 2, and beta is equal to minus 1 minus root 3i whole divided by 2. This is one complex cube root of unity. This is the other complex cube root of unity. This we are calling alpha, this we are calling beta. We have to show that alpha and beta, they are the reciprocal of each other. Alright, so what we are going to do, we will show that alpha into beta is 1. We will show that alpha into beta. Alright, alpha into beta is equal to 1. If we are able to show this, that means alpha is equal to 1 upon beta, or beta is equal to 1 upon alpha. That means alpha is the reciprocal of beta and beta is the reciprocal of alpha. And that's the property that each of the complex cube roots of unity is the reciprocal of the other. Alright, so actually we have to show that alpha into beta is equal to 1. This we have to show. Fine, so let's do that. Alpha into beta is equal to 1. Can I rub this? Alright, so alpha into beta. Alpha into beta. Alpha and beta. This is equal to. Alright. Into. And this is again 2. Here minus 1 plus root 3i, and here minus 1 minus root 3i. Fine. Okay. Now this is equal to. This is equal to again a plus b into a minus b. Just now we have done same thing. A plus b into a minus b, which is a square minus b square. That means minus 1 square. A plus b into a minus b is a square and minus b square. Fine. Clear? And whole divided by 2 to the 4. And this gives you minus 1 square is 1, and this I am writing directly now 3i square. I square is minus 1. So minus 1 into 3. This will be 3i square, minus 3i square, I square is minus 1. So 3 into minus 1 is minus 3, and this minus, so plus 3. Alright. Plus 3 whole divided by 4. And this gives you 4 whole divided by 4. And this gives you 1. So we got alpha into beta is equal to 1 finally. Okay, now let me tell you. What does it mean? We got alpha into beta is equal to 1. So alpha beta is equal to 1. Now it means alpha is equal to 1 upon beta, or beta is equal to 1 upon alpha. Isn't it? Beta is equal to 1 upon alpha, or beta is equal to 1 upon alpha. And this is the result. Alpha into beta is equal to 1. So you can write, no, alpha is equal to 1 over beta, or beta is equal to 1 over alpha. And this is the property, no? This is the property. The property says that each complex cube root of unity is the reciprocal of the other. Each complex cube root of unity is the reciprocal of the other. 1 upon alpha is equal to beta. 1 upon beta is equal to alpha. Alright? So I hope all these 4 properties are very, very clear. Even now you know how to prove it. Alright? And the results are very, very important. That 1 plus omega square is equal to 0, and then omega cube is equal to 1, like that. Okay, so these 4 properties, once again you do practice, try to do on your own. I hope everything is very, very clear. Okay, then thank you so much. Thanks.